Welcome to the Real Python Podcast. This is episode 64. Are you looking for an in-depth data science project to practice your skills on? Or perhaps you would like to add new tools to your Python web development projects instead? This week on the show, David Amos is back, and he's brought in another batch of PyCoder's weekly articles and projects. David shares an article about how to go about detecting deforestation from satellite images. He covers how a data science team built a machine learning solution to do just that, using FastAI for the modeling and Streamlit to create a dashboard. We also discuss a Real Python article about building a blog using Django, Vue.js, and GraphQL. GraphQL is a great tool to enhance your API to make it more flexible. The step-by-step project walks you through turning your Django blog data models into a GraphQL API. We cover several other articles and projects from the Python community, including the tools and tech used to run a one-woman hardware company, visualizing data in Python using plt.scatter, why the sad face when using black, how to iterate over DataFrame rows, and should you? pipx is now a PyPA member project, and real-time lossless audio compression in Python with pyFLAC. This episode is brought to you by DigitalOcean's app platform. All right, let's get started. The Real Python Podcast is a weekly conversation about using Python in the real world. My name is Christopher Bailey, your host. Each week, we feature interviews with experts in the community and discussions about the topics, articles, and courses found at realpython.com. After the podcast, join us and learn real-world Python skills with a community of experts at realpython.com. Hey, David, welcome back.
Hey, Chris. Thanks for having me back.
All right, we got a whole bunch of PyCoders goodness here.
Yeah.
I'm going to start off mine this week talking about Real Python article from previous guest, Dane Hillard. Dane Hillard was on in episode 49. He was talking about his book, Practices for the Python Pro, and kind of what makes the term professional developer. And near the end of the episode, he dove into something he was interested in learning about and working with, which was GraphQL. And I guess he was probably already starting to work on this article at that point. And this is another step-by-step article on Real Python. So it's not a super deep dive into the technology, like describing it in sort of like research on that. It's much more of an implementation and learning how to use this and set it up and kind of get your chance to play with a lot of this technology. And so it's called Build a Blog using Django, which we've covered multiple times. But then the next two commas are Vue, which is a JavaScript library, kind of similar to React in some ways. And then GraphQL, which is what he was talking about briefly at the end of the episode. He was mentioning that he was interested in this query language, and I was not that familiar with it. And I've learned a lot more about it. And I'll include some additional resources. There's a JavaScript sort of centric podcast, web development podcast called Syntax. And they have an episode where they talk about GraphQL in a lot more detail. There's a lot of information out there. It's sort of originally developed in the Facebook camp, and it's open source. And since 2018, it's become a pretty popular way of sharing APIs.
Mm-hmm.
And those of you who've maybe played around with APIs a little bit, there's sort of this problem of having to set up an endpoint for everything you kind of want to access, or the reverse of it is you set up an API and then it dumps like this huge amount of data back at you. And it would be nice to be able to kind of, sort through that and sort of query that and narrow it down. And that's really the idea behind GraphQL. And it's hard to really explain in this format. It very much looks like JSON. The querying is very JSON-like in the sense that you're specifying the attributes and things that you want to pull out of this information. But it's pretty neat, and it allows you to move beyond like having all these separate endpoints and the pile of information you get back, and you can kind of specifically ask for what you're looking for. And then you can use it on the client side requesting it, but you can also, so like if you want to talk to other tools that are out there that are using GraphQL, or you can use it and set it up on your own on the server side. And kind of interestingly, this tutorial takes you through kind of setting up both sides. It starts out with really just getting going in Django and setting up the architecture there and using that as your initial like layout. You not only install Django and get it set up, you create some simple models for a blog that go a little further in the sense that they now have like, okay, there's an author and some additional fields that make sense inside there, publishing dates and things like that. Kind of, fairly standard, but more than the usual. And you can kind of see why you may want to do that, to be able to see all this extra information you might want to look through. Once you get the Django blog set up, you set up the admin, and we have some other additional courses on this that kind of dive into the admin side, where you can kind of customize, how it looks and feels, and what kinds of things that you want people to be able to enter from the admin side. And then jumps right in step 3, setting up this thing called Graphing Django. And so that's the library to sort of do the requesting and talking between Django and the GraphQL services. And then eventually you get into the step where you're going to be installing Vue.js and setting up a Vue router to help with this. And that's where you're kind of delving much deeper into JavaScript and working with it. And again, like all our tutorials, the code's all there. So you can either, as you work along, copy and paste the code from the article as you're working. But it's all also available in the GitHub repository, so you can kind of compare what you've created and check it all out. So anyway, so eventually you're kind of building up this router, and then you're creating the separate Vue, what are called components. And they're very similar, in my opinion, to like, the models and things like that. But once you kind of get it set up, there's like these two different sort of endpoints that you're setting up. Your server will have a slightly different port than what's happening from the Django side. So like 8,000 versus 8080. And so you're kind of talking back and forth on your local machine, kind of, fetching data and pushing it back and forth. It's a really fun kind of way to kind of explore and learn a little bit more about this stuff and see how, not only how you might implement Vue, but this very advanced, way of working with APIs that really looks like, kind of the future of how you could work with APIs in a much more elegant fashion of like getting to the specific things that you want. And then also from your side as a developer, it's much easier to sort of update and change your API just by sort of restructuring the code that's kind of inside there in the GraphQL language stuff that you're working with. So I think it's a neat one to check out.
Yeah, I really like this step-by-step project format. And, we've got more of these coming down the pipeline. And you're right, this really isn't, this style of article is not really about teaching you about the different technologies as much as it is showing you how to combine things you might already know about into an actual project.
Right.
Which I think, fulfills a need that kind of goes beyond just like a tutorial on, just Vue itself or just GraphQL. You really integrate those things and see how they all fit together in an example project. And it could be a launching point for you to then go on and create your own thing. So,
right.
So yeah, it's definitely fulfilling a different need than like, it kind of assumes, for example, something about Django, something about Vue. Maybe something about GraphQL. It's not really necessary because you can kind of copy and paste and follow along. And Dane does a great job of sort of showing you at each step, like what your project structure should look like what folders and files you should have and where they are. So you can, if you don't really know too much about Vue or JavaScript, you can still make it through the end of the project and have something that's working. But yeah, it's just a great way to see how different things integrate with each other and get an example project going.
Yeah, I really like the idea of like standing stuff up and then being able to sort of poke at it, So
right.
If you were to then go and look at other resources to learn more about Vue or to learn more about GraphQL, now you have this working project and you're now able to try those techniques out on your own services that you've set up,
yeah,
and can sort of customize them. And so I think that's a nice practice.
For sure.
more than just sort of following the step by step, which is always, good to kind of get the muscle memory of typing things in.
Yeah, for sure.
Yeah. So what's your first one you got?
First one I got is called Detecting Deforestation from Satellite Images. This one comes from Andre Ferreira. It's a full stack deep learning project, and it's sort of similar to what we just talked about with Dane's Django Vue GraphQL. It's kind of a end-to-end, like we're building this project together. It's not quite the same kind of step-by-step format that we have on Real Python. This one is a Medium article on the Towards Data Science blog.
Yeah.
But it's a really good example of, again, like how you would approach putting together a data science machine learning project end to end, like starting with, they even start with, for example, like, okay, what data set are we going to use? They investigate a couple of different data sets and they make a decision and they explain why they picked that particular data set, then what model they're going to use, like what package are they going to use for the model, for the machine learning, how are they going to present the information and the results, what kind of dashboard are they going to have. It just is the whole 9 yards. The article is not incredibly technical in terms of there's not a lot of code in the article. They've got links to the project repository on GitHub, so you can go and you can look at all the code. But it really focuses more on the decision making process in this and sort of like what they were thinking about. They were trying to build sort of a minimum viable product of something that could be used to detect where deforestation was occurring from satellite imagery. And they start by looking at kind of a plan for the project. They say, okay, so what does this thing need to do? And of course, that, is a great first step for any project. Sit down and sort of map out like, okay, what is it that we actually have to get done here? What are kind of the key points? So they talk about, for this MVP, the minimum viable project, what do we need to have? Well, we need to have a model that's trained and has acceptable performance on detecting deforestation. We need to have a dashboard to show the predictions on the data set. We want to have a GitHub package. We want to do some hyperparameter tuning, that is, optimization to improve the model. And we want to have a robust data storage solution for the project. So these are kind of like the minimal goals they set out ahead of time. They talk about some like things that would be nice to have, things like what they call out of domain or distribution shift analysis. Like they, if they have the time, it'd be nice to study the model's performance on data that's different from what it was trained on to kind of see how it works there. They'd like to have tests for their package. So yeah, they talk about, kind of these nice to haves and really lay out like a roadmap for like, okay, this is what we want to get done for the project. So it's really cool to see that, the things they're thinking about, what they're looking for. Like I said, it's really kind of a guide to like, how would you approach building a project? So then they go into, okay, how are we going to do this? Like, what are we going to look at? Where's our data going to come from? So they talk about, doing a bunch of research, looking at a bunch of different data sets. And this is not, exploratory data analysis. This is just researching what data sets are available, maybe looking at kind of the raw data just to kind of see like what's in there and might it work. They narrow it down to 3 data sets. There's a data set of images from the Amazon from space. There's one called the WIDS Datathon 2019, which has got oil palm plantation detection in Borneo. And they've got another data set called Towards Detecting Deforestation, which is a data set for detecting coffee plantations in the Amazon rainforest. After they look at this, they narrow it down to this Amazon data set, which is looking at the human footprint in the Amazon rainforest. And they decide to go with that data set for training the model. Then they get into the exploratory data analysis and data processing phase. So they kind of talk a little bit about what they were looking for in this data set, what was available, some of the plots they were making to sort of understand what's there, things like tagging, stuff like that. So they really get into how they were approaching the exploratory data analysis. And they do some of that on some of the other data sets too. And they kind of compare notes and they sort of explain why they picked the Amazon data set. Then they get into the model, how, what sort of model are they actually going to use here? And do they need to build this model from scratch? Is there something available? They decide to go with FastAI, which is a really cool project. From there, they kind of talk about, okay, how are we going to set this up? Like what FastAI model are we actually going to use? They use something called the ResNet 50 model, which is a convolutional neural network with 50 layers. They show a little bit of code on, how they're kind of setting this up and working with the FastAI and kind of showing how FastAI takes care of a lot of things for you. So nice little code snippet just showing how they can kind of quickly get this set up. And then they get into, okay, we've got our model, we've got our data. How are we going to display the results, right? So what about this dashboard? And what are some of the things we want to include? They end up deciding to go with Streamlit, which I believe we've talked about on the podcast in the past.
Yeah.
Really cool library for making dashboards. Again, they're just discussing this whole decision-making process in all of this. Then they get into the data storage. They end up going with some solutions on Google Cloud and talk about how that's integrated and everything. Yeah, it's just a kind of a walkthrough end to end, like, here's what we want to do and here's how we're going to go about building it and why we made the decisions we made. So it's really, if you've been studying data science and machine learning and you're still kind of maybe stuck on like, okay, how do I actually put all this together into a full project? Well, this is a really great example of how you do that and the kinds of questions you should be asking and the thought process behind making some of those decisions. So yeah, hands off to Andre. This is a fantastic overview and article and a really great resource.
Nice. DigitalOcean's App Platform is a new platform as a service solution to build modern cloud-native apps. With App Platform, you can build, deploy, and scale apps and static websites quickly and easily. Simply point to your GitHub repository and let App Platform do all the heavy lifting related to infrastructure. Get started on DigitalOcean's App Platform for free at do.co/realpython. That's do.co/realpython. This week I have articles and features that are all from previous guests.
Yeah,
it seems like. So this next one is from Stargirl Flowers, who was on episode 5. We were talking about Circuit Python at the time, and she has created quite the little hardware company in the last year. It's kind of amazing.
Yeah.
And she's getting her stuff distributed in multiple places now. And so she decided to create a post sort of explaining, and the title of it is The Tools and Tech I Use to Run a One-Woman Hardware Company. So she's been making these boutique synthesizers and Eurorack modules, and there's quite a bit that kind of goes into sort of turning it into a company, and not only just like it being like just a small project of designing hardware, but also in a lot of cases those pieces of hardware need microcontrollers, and the microcontrollers need firmware. Then there's the whole levels of like documentation and building and things and so forth. And how can a single person do all that? And so it's a really neat article, kind of diving into it. It touches on Python quite a bit, but it also just sort of kind of looks at like as a technological thing, like kind of thought processes that would go into it. So it sort of starts off with like kind of an overall philosophy. And she has a quote from Gunpei Yokoi, and his quote is lateral thinking with withered technology. And that's kind of her philosophy, is sort of following that same idea, is to leverage things that she already knows and is familiar with and can be fluent with, but also look at things that are not necessarily the cutting edge all the time.
Right.
And what helps with that is not only can they mainly be more understood because they've been used in other projects or they've been documented, and then also in a lot of cases they're already kind of being maintained by others.
Exactly.
And so that really led to the types of microcontrollers that she's using, and the main ones that she's been focusing on and literally choosing the chips to do this, they're from a company called Microchip, and the series is the SAMD series. There's like 3 that she focuses on. There's like a nice table kind of explaining, everything from like the processor speed to like sort of ins and outs that they can handle in communications, and then also like how much RAM they can have, which is really small. So thinking about like, trying to program these things.
Yeah. Measured in kilobytes.
Yeah. You're very, very small.
Yeah.
So these are similar microcontrollers to what's in the Arduino Zero, which is a very popular kind of like, prototype board and stuff to play around. And then the Adafruit boards, which my project that I'm kind of messing around with uses this M4 style board. They also have an M0 board, and there's a few others that she kind of leads out to. So it goes into that whole reasons for choosing those and why working with them. And then she talks about hardware design, which she did go into in our episode, talking about this thing called KiCad, KiCad, and it's an open source design tool for designing circuit boards. And I got into electronics years ago, and I was playing around with the idea of building like guitar pedals and things like that. And I had this ancient book from a guy who's really famous in the DIY electronics space back when I got into it. And his name's Craig Anderton, and he had this great guitar projects book. And unfortunately, most of the kits that he's talking about there, would use parts that would be probably hard to find now and things that have been replaced and so forth. But if I wanted to take some of his designs and I wanted my own, board design with certain layouts and so forth, this thing called KiCad is really neat for doing that. And she's had experience creating this Genesis synth called the Genesynth, and then it led to her two other projects. And now she's got like a synthesizer one called Castor and Pollux, and then another new one that she's working on. Anyway, so KiCad's a nice tool for that if you're interested in designing actual circuit boards and hardware for that. And then it's surprising that with the resources now, getting prototype boards or actually getting actual printed boards doesn't require you to make thousands of them, which is really nice too. Then it goes into firmware, and she is using C, which she has a background in, not offshoots of C, but actual just pure C. And then talks about the compiler that she's using there, goes into firmware libraries. And again, this goes into the withered idea, the idea that using some existing firmware libraries will be helpful for documentation and building upon. She has links to all the repositories. I don't know if I mentioned it, but she considers the whole company an open source company. So the designs are open source, the firmware is open source. Like she wants to, give back to the community in the same way that, she's getting in this way, which is really neat. So you can kind of, a lot of people ask about like checking out code and so forth. This is a really neat one, especially it gets into this idea of build systems and running those compilers and, outputting firmware. She uses Python and a build system called Ninja. And then it kind of wraps up kind of talking about Python-based tooling that she also uses, and then kind of dives into Circuit Python. And her first two projects, the Big Honking Button and Soul, are both these Circuit Python platforms.
Yeah.
It's a really neat platform. And I hoped I'd be talking about it a lot more. We talked about it in that episode, but the idea that you can just plug in a USB port of your computer and, up pops up, a little .py file that you could just start writing Python into and then send it over, and it starts working on it. It's just so cool. And then when you unplug it, if you have a power source or what have you, you're running that code. It's really slick. Then it kind of wraps up on documentation and creating user guides. And she's a fan of Markdown and using this tool called mkdocs to convert the Markdown into web pages. And she's hosting them up on GitHub pages because it's all just static files, sort of stuff. She hasn't dived into the latest JavaScript stuff that we were talking about earlier. She's trying to avoid some of the Node.js ecosystem. It's just huge and hard to stay on top of. And if that's not really your focus, then that makes sense. And so she's created her own little JavaScript library for working with things that are useful for what she's trying to document and show and create in there. And that involves working with audio elements, to actually play little audio snippets, creating forms, and then another tool which allows there to be web MIDI playback.
Yeah.
And I'm interested in that one to see kind of what's there. But so her Winter.js JavaScript library is up on her GitHub stuff too. So it's just a neat article kind of diving into all that sort of stuff. If you're interested in the electronic sides of things, but also the idea of like, okay, if you're going to create sort of an open source not only project or company, like some good best practices there. And she's been a maintainer of projects for a long time and was a PSF fellow the previous year. And so anyway, neat article. Check it out.
One thing I want to point out on Stargirl's article is that, and she kind of explains this kind of throughout. There's little mentions of this, all the decisions that she's making are coming from the standpoint of, I'm working on this by myself. I have to do everything.
Yeah.
And there's a really, I think, interesting comment here at the end of the JavaScript section of her article that says, if you're a JavaScript developer and you go digging into my JavaScript code, you might find some of my style choices offensive. I use 4 spaces and a snake case, right? So
right.
And, and she says, I do this so that I'm consistent with the C and Python code, which makes context switching much easier for me. And to me, that is it's really great advice, right? If you're a single developer and you have to deal with multiple languages and you've got common style that is valid in those different languages, why not use it? So that when you're context switching, it's just easier to deal with. The formatting looks similar, just easier to digest. And yeah, if you've got a team of people that are working on this and they're kind of isolated from the people that are working on the other components of the ecosystem, then sure, they can follow the style guides and, whatever best practices they decide on and everything. But I don't know. I just thought that was kind of, it sounds sort of, in a sense, defensive, kind of like she's defending her choices from, potentially
right.
people saying, look, this is not the way you should write JavaScript. But I also feel like it's a really powerful lesson there for folks that are in a position of, look, you're trying to do something by yourself. You need to maximize your productivity. And to do that, you have to make decisions that make it easier for you to context switch and to maintain things yourself and all of that. So anyways, just thought that was a really kind of powerful lesson and something that, there might be kind of a mentality of I'm learning JavaScript now, so I need to write my JavaScript according to whatever the current standards are and everything. It's well, if you're on a team that's doing that, or you're trying to get a job at a company, yeah, you probably want to be aware of that stuff. But, if you're just trying to get a job done,
right,
focus on what maximizes your productivity. That's the most important thing.
Yeah, I think I missed one of the other main themes that I should have included also is the idea that across the board, thematically, the idea is, again, for a single person trying to do everything, is to, literally not use up as much energy and resources and be as, all those things. You only have so much time, you only have so much energy.
Exactly.
But in the same way, materials wise, if you can keep reusing the same materials, that's great. But she wants her projects and the things that she builds to be, with this, we're dealing with this global chip shortage, right?
Yeah.
So if you were to use a project like the Soul project that she has, that is this reprogrammable sort of control voltage to MIDI tool, but if you can go in and make it do your own thing by reprogramming it, then you're not buying additional hardware. You're not, throwing something else into the dump. You're actually looking at ways that you could own this hardware a little more and reuse it and modify it. And that's something that she kind of really focuses a lot on throughout the article too, which I kind of missed earlier.
Some sustainability.
Yeah,
there.
totally.
Yeah.
There's a sustainability as a human being as far as your own life and time and energy, but also just, from hardware also, which I think is a really kind of neat focus too.
Yeah.
Cool.
For sure.
So what do you got next?
Next up on my list is another Real Python article. It's called Visualizing Data in Python Using plt.scatter. This comes from Stephen Gruppetta. And this is kind of an introduction to creating scatter plots. It goes a little bit beyond just an introduction, and you learn a lot about making and configuring and customizing scatter plots in Matplotlib. It starts with, how do you create a scatter plot? What is a scatter plot? There's this function called scatter that you use to make scatter plots. And it gives a very basic example of how you do that. Here's some data points, and let's plot them. So he's got basically an example where you've got a cafe that's selling 6 different types of bottled orange drinks, and the owner wants to understand the relationship between the price of the drinks and how many of each one that they sell. So you plot price against sales per day, and you get the scatter plot. You can kind of see a relationship there. So you get this basic example. One of the things that I learned working with Stephen on this article and in the outline and technical review phases was that there's a difference in performance between using the plot function, which is kind of the general plotting tool in Matplotlib, versus the scatter function. So you can create this exactly the same scatter plot as far as the final product goes. It looks exactly the same using either the plot function or the scatter function. But there's a performance difference, and plot is actually more performant. So that was something I wasn't aware of and hadn't even really thought about. It just seemed like, okay, if I'm making a scatter plot, I want to use the scatter function, right? Well, in probably 90% of the cases, you want to use scatter. But if you really need the performance, then you want to use plot. If the performance is important and you don't need all the customization that scatter provides, then the plot function is going to be what you want to use. It's something on the order of like 7 times faster than scatter. So that was something that was really interesting and something new that I learned from the article. From there, Stephen goes into talking about how you can customize things, how you can change the size of the dots in your scatter plot, the color, the shape, and the transparency. And the transparency aspect is something that is really neat because in a scatter plot, you have these dots plotted all over the place. And there's unless your data set is like really sparse, you're probably going to have a lot of overlap. And you might not know like what the density of like how many dots are there really in this region of the scatter plot. If you adjust your transparency a little bit and make the dots semi-transparent, then all of a sudden you gain like an extra dimension almost into your data, where you get to see like, oh, there's a lot like of points in this region, and it looks really dense. And that's something, an important piece of information that you can get there. So adjusting the transparency is one of those neat little tips that you can get with the scatter plots. He talks about color maps in Matplotlib and how you can use them with scatter plots and customize all that kind of stuff. And so, yeah, really just really dives into how to use this scatter function, what all the different options are available to you, and how you can customize it. So it's a really nice. It's not too long. It's also not super short either. It's kind of a nice medium length article. It's got, I think, a really appropriate level of depth where it's like if you're brand new to Matplotlib and you're looking for some, information about scatter plots, this is a fantastic resource. If you're looking to dive a little bit deeper into scatter plots, then this is also a fantastic resource. So it's really, I think, something, if this is something you're doing day in and day out, you'd probably want to bookmark this and just kind of keep coming back to it as a nice reference.
Yeah, it's kind of amazing with data visualization. You learn these sort of like thematic elements, but going into each style of plotting, there's so many ways that you can apply it. And, like things like you're mentioning of graphing across different colors to kind of show another dimension there, the opacity and, how transparent things are and how you can make it seem like things are stacking up and adding these additional dimensions. And then also just, ways of like interacting and having the legends and other things kind of work with what you're trying to do. It's definitely a deep subject. So that's kind of nice to see this sort of deep dive into one specific area. And I'm sure it kind of maps across additional ones that you might want to play with in your data visualizations.
Yeah.
My next one is, again, from previous guest. This is from Łukasz Langa. And we talked about his project Black on episode 7. He actually mentioned this briefly in our conversation, but this is a nice article really distilling his thoughts on it. And he was kind of mentioning in sort of an offhand way that some people were unhappy with the way sometimes Black would look for what they were trying to do. And one of the main ones they were complaining about is this idea of this, they call it the sad face dedent.
Yeah.
And it's pretty common if you have a lot of parameters, or you're setting up a list, or you're setting up a dictionary, to format things where you sort of open up, in this case, an opening of the parentheses and then closing the parentheses, and having those on like a separate line so that all this individual elements that you're working with, parameters or what have you, are on a separate line with a comma and so forth. And then one line down at the very end of it, you'd be closing that off, and in this case it would look like an unhappy face because it's a closed parentheses and a colon.
Right.
And so
for a function or a class or something like that.
Yeah. So when you're defining those things, or like an if statement or some other kinds of things where you might see that. And so some people don't like that style, but he explains why it's actually kind of a best practice in some ways. And so there's some things that he says that might surprise you. It kind of follows this sort of, he sums it up with the consistency that all the bracket pairs are treated equal. So it could be, curly brackets in the case of a dictionary, or, square brackets for list, what have you, but treating them all kind of the same in that style. His other one is readability. The function signature or if statement or while test and so on is going to be clearly delimited from the body of it.
Yeah.
Which is really much easier to kind of read and look at. And then he goes into developer efficiency, which this is the one that I think was the most surprising to me, but made the most sense to me, of like, oh yeah, this is going to save a lot. It has to do with diffs, or, seeing the differences between two different files.
Yeah.
And where you would see this is like, if you have all those elements, maybe they're parameters or whatever that you're sort of explaining in there. And let's say you don't use the practice of putting a comma on the last one, and then you make a change to that last line. Just adding the comma makes that a diff. And so it flags that entire line as a change. Then the new line that you've added, and then, and so forth. So like if you were just going to change a single thing, like you thought I was just changing this one line, it looks like you're changing like 3 lines. And the article kind of shows that. It's a very short article, but it kind of graphically shows that really well to kind of explain it. And so kind of diving deeper into the idea of the bracket pairs treated equals, like, you can do multi-line lists and dictionary literals when you're calling, functions and seeing those, and importing, maybe you've seen importing multiple names from a particular library, from this import, and then like the parentheses, and then have like multiple things that you're bringing in. Again, stylistically, just kind of keeping it going through everything. The one also, I've been doing a bunch of courses about Boolean expressions lately, reviewing them and kind of going into them. And the idea of like those really complex sort of compound Boolean expressions sometimes you might have in describing something, of like, and this or that or whatever, and having them on separate lines makes it way easier to parse in a lot of cases. And so, and then just blocks of code. In the end, what do you get? You get clearly delimited block header from the body. It's going to minimize the diffs. It neatly leaves a space also for like return type annotations, which again, if you're doing annotations, it then shows the little sad face and then like your arrow and like, okay, this is what it's actually, going to return here. And you can annotate that very clearly outside of the confusion of the whole body of things. It's a nice way explaining like why the auto formatter Black is doing this, but also why it's a good practice.
Right. Yeah. Something I just want to add about this isn't necessarily about the sad face dedent as he calls it.
Okay.
But putting, like, if you have a long list,
yeah,
putting each item on its own line has a lot of advantages. And one of the nice things is you can sort of like quickly like comment out.
Yeah. Try things.
Portions of your list, right? And like, so yeah, there's just a lot of, I think, advantages to doing that. And yeah, if you measure things in terms of lines of code, this kind of style adds a lot of lines to your code.
Right.
But, I think the advantages sort of outweigh that in a lot of cases. So yeah, it's a nice little explainer of why there are actually some like objective benefits to this. And it's not purely like a subjective style choice.
Yeah. Kind of going back to the the data visualization thing, when you're creating these plots and graphs, very often there's like, a mass list of parameters that you're putting into it.
Right.
And that's a really common thing, what you mentioned of commenting them out. It's like, okay, well, let me try this without these things, and just to be able to throw a comment. Or like we were mentioning the idea of like, you go into do a diff to kind of see what's changed between these things. It's much easier to see that in red than it across like the whole body of the thing, and you're having to parse yourself where it is. So
exactly.
I want to shine a spotlight on another Real Python video course. It dives into the topic of working with data frames in Python. It's titled Explore Your Dataset with Pandas. The course is based on an article by Rika Horvath. And in the course, Douglas Starnes takes you through how to calculate metrics about your data, perform basic queries and aggregations, discover and handle incorrect data, inconsistencies, and missing values, and then how to visualize your data with plots. I think it's a worthy investment of your time to learn how to wrangle data using pandas, whether you're calculating grades, managing a data science project, calculating statistics, or building dashboards. Our video courses are broken into easily consumable sections. Where needed, we include code examples for the techniques shown. And all the lessons have a transcript, including closed captions. Check out the video course. You can find a link in the show notes, or you can find it using the newly enhanced search tool on realpython.com. So what do you got next?
Next one I have comes from someone we featured a couple times now, I think, on the podcast. This is Matt Wright. He's got an article over on his blog, writers.io, called How to Iterate Over DataFrame Rows, and Should You? So this is an interesting article because it kind of ties into something. I can't remember if we talked about this on the podcast. Maybe I mentioned it in one of the news articles or something like that. But Stack Overflow recently did kind of some data analysis on data they'd collected about what are some of like the top voted questions, and in particular, what's the most copied answer within a code block. And it turns out that the most copied answer within a code block on the entire site is about iterating over rows of a data frame, of a pandas data frame.
Yeah.
So this is kind of addressing that. It's such a common question. The answer to that question is is the most copied answer on the entire Stack Overflow site, at least, at this moment. It kind of bears looking into, well, should you actually do this? Like, is this actually a good thing? And you think of a data frame in some sense as like a two-dimensional or multi-dimensional array. And a lot of times in programming, you do a lot of iterating over arrays. Well, data frames are not really, they're more than just an array. That is sort of the underlying data structure of them, but they're sort of more than that. It's a way of working with data that doesn't require, in most cases, I'd say in the vast majority of cases, any kind of direct iteration. So this article talks about like, okay, if you need to iterate over rows, here's how to do it. Here's some ways to do that. And he talks about a couple of different ways to do that. And I'm not going to talk about how they work. I mean, you can read the article, you can see the Stack Overflow answer and see that. But he says, okay, is this really your best choice? And when he comes down to it, like the final solution that he comes up with for iterating over, and I think this goes back to the Stack Overflow answer, is using something called iter rows, and says it seems really easy, and you can see why it's the top voted answer, because it does exactly what you want. Why would there be any controversy? And it comes down to some speed and memory.
Yeah.
When you're working with really large data frames, speed is very important. And NumPy, which is sort of the underlying library in pandas, all the data frame and everything, they're all implemented as NumPy arrays, kind of at the base level, has some techniques that they're not specific to NumPy. It's really just a general array technique, something called vectorization. And there's also kind of a related concept called broadcasting. And this is a way that you can look at things in, aggregate, or sort of perform operations on multiple rows without having to do any kind of looping or iteration. And it's extremely powerful. It's orders of magnitude faster than just doing a simple, for loop or something like that over this like iter rows. So he gives an example of he's got this example that he's using throughout the article of scoring things, like giving like letter grades to things. And he runs a vectorized example of doing the same operation, assigning these letter scores. And the vectorized thing runs on his computer in about 2.75 milliseconds, whereas the iterows implementation of that takes 13.5 milliseconds, which is quite a big difference.
Yeah.
So you're almost 5 times faster, and that's just with this, tiny data set. And it gets into things like, Python and list comprehensions and some other techniques. There's the apply method on data frames can be used to apply things to multiple rows, and it talks about some different techniques. But really, it's, I think kind of the point of this article is, if you find yourself wanting to iterate over rows in a data frame, you probably need to stop and ask yourself, do I really need to do this? Or is there some better way that's more performant and really more, I don't know what the corresponding term for Pythonic would would be for like pandas or something, but like I guess just more like a better practice, things like that. So yeah, it's a really neat article. It's really in depth. It does cover a lot of ways to iterate over rows, because there might be times you really do need to do that. I think it's going to be in rare cases, but overall, you have multiple choices, and doing something like vectorization, which pandas and NumPy together make that pretty simple, is often going to be a better choice. And he does give kind of an overview of, how do you decide and when should you use these different techniques. So he's got a chart of exploring kind of the runtime of all these different ways of doing things, and when it might make sense, when it might actually be more performant to do something like, iter rows or iterating over something. And it really comes down to, how big is your data set, and what can you write and maintain easily. So those are kind of the two things he suggests to think about when looking at this. So yeah, if you use pandas data frames a lot, if you found yourself wanting to iterate over rows in a data frame, highly recommend checking this article out and getting a good look at what all the different options are, and how vectorization comes into play, what that is, what that means for performance, and how you might go about choosing to do that.
Yeah, we have a really good course. I'll probably feature it in this week's spotlight, about working with data frames and sort of exploring the data inside them. And it kind of talks about a lot of those kind of ideas too. And
awesome.
The idea of like the series inside there, and lock and iLock and these other kinds of tools that are kind of important to just be familiar with, as opposed to just brute force applying things. Yeah.
Right.
Cool. So this brings us to projects. And the one that I have is really kind of interesting. It's from Sonos, the company that makes a lot of these nice Wi-Fi speakers and other kinds of technological audio projects. And they are working with this codec called FLAC, the free lossless audio codec, which, if you're an audiophile, you might be familiar with this already, because of the idea of like, not working with MP3s and these other lossy compression things. I don't want to get into that debate here. This is more talking about using FLAC very specifically for their own tools. And so they created their own library called pyFLAC to be able to use FLAC in their sort of data science and measurement processes and so forth. And they pick FLAC partly because of the idea that it will reduce the size of things, and the library that they're using that's inside there is written in C. And by converting it to Python allows them to do what we've covered many times in this show, is the idea of like rapidly developing solutions and trying things out and experimenting, the way that data science really, is all about Python in that way, the idea like quickly trying things out and modifying stuff.
Yeah.
So why do they need FLAC in this particular case? Why do they need it to be lossless audio? Is a lot of the tools that they're designing are for within these speakers. The speakers can determine the room that you're in. The speakers have their own microphones. They can actually analyze their own playback and sort of tune the sound of the speaker to the acoustics of the room. And so that goes beyond like the whole argument of like human hearing and so forth and what gets thrown out that supposedly can't be heard. Here you're really wanting to measure the full spectrum, really get an idea of measurements across all the different surfaces of what's being reflected, what's not, and so forth. And so it's very important that it is really included in this whole thing, even though you might get into the whole perceptually redundant information idea. But in this case, for the machines measuring it, they need it. And their technology is called TruePlay. If somebody has like a Apple product, you might have heard of this thing called the HomePod. It had a similar kind of thing where like if you picked it up, it could sense that you've moved it and it would then recalibrate itself to, where you're moving it in the room. And so their technology is very similar in that idea. So the library, by them open sourcing it, allows you to kind of play around with, not only doing real-time analysis with FLAC in your own Python projects, but also as a command line interface. Actually, a couple of things about it. Number one, pyFLAC is pip installable, so you can get it actually from PyPA. I'm going to include the GitHub repository. And then one other kind of nice thing is just right out of the box, it has a CLI, command line interface, that you can use with the library to do conversions from a wave to a FLAC file and back and forth. And it runs on, all the main operating systems, Mac, Linux, and Windows, but also the Raspberry Pi and Raspberry Pi Zero.
Cool.
So if you're looking at using it in, kind of projects and stuff like that, it might be a handy library there, which I know a lot of people are messing around with that kind of stuff. And if you're interested in, having audio playback and have a fancy player and working with FLAC files, here's a nice tool that got open source from Sonos. So
yeah. And actually, I think that it's, if you want to work, like if you just want to read and write FLAC files, there's already an existing solution for that. And I was just kind of browsing through their announcement article, and it looks like they're using that. It's called PySoundFile.
Yeah.
But what pyFLAC, I think where it really shines, and they mentioned this, they say there's so many different existing Python implementations for FLAC encoding, decoding. However, these tend to operate on files rather than real-time streams, which is no good for continuous processing. So that's really where pyFLAC is focused on, that processing continuous streams of data. So
nice. Yeah, and keeping it so that, this data can be huge depending on the sample rates and the bit depth. So it kind of gets up there. And so the idea of reducing it is really going to help as far as working with the data. So
yeah, and Sonos, is a really interesting company. Just to kind of throw this out, this is not Python related, but the first real programming job that I had, like professional programming job, was building these interfaces for audiovisual systems. And it was not using Python. Actually, most of the coding was done in Lua, but we actually worked with Sonos, and they're expensive. They're pretty expensive speakers, but I was always pretty impressed with what they were able to achieve in their devices. They're pretty neat little speakers. So yeah, cool stuff. They got a lot of cool stuff going on there.
Nice. So what's your project?
Mine is not necessarily a new project. It's been around for a few years now, I think. It's called pipx, but I wanted to feature it because they just kind of had a cool news item related to them. That is, they became a member project of the PyPA, which is the Python Packaging Authority. And pipx is a tool for installing and running applications in isolated environments. So you can think of it kind of like pip. You use it to install packages from PyPI or other sources. Basically, anywhere that pip can install from, pipx can also install from that. But in pip, it's just installing into, say, like if you're just running it sort of globally. It's installing it into like your global environment. There's no isolation or anything. If you're using virtual environments, that's a little bit different. pipx automatically installs packages into an isolated environment. So where this really shines is, let's say you want to install a command line tool from PyPA. You can install that tool in isolation, but still have access to it from the command line and be able to run it like you would normally, which is really cool. That opens up, being able to have potentially different versions of that tool installed and have access to those. And it makes sure that, any dependencies of that project aren't going to conflict with any dependencies of another package that you've installed, which is it can be another thing that can be kind of a hassle to deal with when you're installing tools in kind of a global context. So that's a really neat feature of pipx. Another really awesome feature that I think is kind of maybe the coolest part of pipx. I don't know. I mean, it's all really kind of a neat project, but they have a run command. So to install something from pipx, it just works just like pip. You do pip install something. Here you would do pipx install something. There's an additional command called pipx run, and that allows you to do a one-off installation to run something. So say you want to try a package out, right? There's some cool new package on PyPI, and you think, wow, I want to try this out, see how it works, see if I like it. Well, normally to do that, you'd probably create a new virtual environment, use pip to install it, and then run it. Well, with pipx, you can use this run command. It will install it in a temporary isolated environment and run whatever you tell it to run. So you do pipx run and then, the package name and then whatever, like if you were running it from the command line, like you would just pass the options and arguments and everything to it straight away. It would run it with all those options and everything that you have. And then you would see the execution, see it work. And then when it's done running, it gets rid of everything for you and leaves the system back the way it was when it started. So, which I think is really awesome. That's a lot of automation going on there and really makes it a nice way to kind of try things out before you decide to install them and use them. So that's really cool. And the deal about becoming a member of the Python Package Authority is pretty cool. So I know of the Python Packaging Authority. They're kind of responsible for maintaining kind of the standards and best practices of packaging things in Python. So, if you're curious to know how you would create your own package, the PyPA has a bunch of tutorials and things like that you can look at. They talk about, the different PEPs involved and what the best practices are and what tools to use, things like that. But they host these member projects. And when that happens, they actually become a part of the PyPA GitHub organization and get hosted there. And I didn't know when I went into this, I didn't really know like, okay, what else happens? Like, what's the advantage of becoming a PyPA member project other than maybe getting like a little boost in visibility or things like that? Well, there's a PEP called PEP 609 that sort of lays out the governance model for the PyPA. And they mention PyPA member projects. And one of the things that they provide, one of the goals of the PyPA is that in the event that a project needs additional support or no longer has active maintainers, then the PyPA will ensure that the given project continues to be supported for users to whatever extent necessary. So it kind of provides some added security and to that project, for people who are using that, they'll know that like, okay, if something happens to the maintainers, they can't maintain it anymore, then it's not going to just die out completely. There's still going to be someone there working on it and providing support as needed. So that's really kind of a neat deal. And it just kind of, I guess it goes to show that pipx is a valued project in the community and something that they want to ensure, has some longevity behind it.
Yeah, it's nice. I'm looking through the other projects that are in there in the PyPA collection on GitHub, and beyond pip and virtual env and a handful of other ones. They're all these sort of tools for packaging, which makes sense. And
yeah,
a lot of familiar names in the people list there.
Yeah.
So there's Stargirl and Brett and a couple other people I'm hoping to have on the show soon. So great.
Yeah.
All right. Well, that's a great list of stuff from PyCoders this week.
Yeah.
Yeah. Thanks for coming on the show again, and talk to you soon.
Absolutely. Yeah. See you around.
And don't forget, you can get started on DigitalOcean's app platform for free at do.co/realpython. That's do.co/realpython. I want to thank David Amos for joining me again this week. And I want to thank you for listening to the Real Python podcast. Make sure that you click that follow button in your podcast player. And if you see a subscribe button somewhere, remember that the Real Python podcast is free. If you like the show, please leave us a review. You can find show notes with links to all the topics we spoke about inside your podcast player or at realpython.com/podcast. And while you're there, you can leave us a question or a topic idea. I've been your host, Christopher Bailey, and look forward to talking to you soon.